Hi guys, we are on page 93, lesson 2.2, problem 2. All right, top of the page. Brody, could you read for us? We have a plane landing in the United Kingdom.
The plane has landed in the United Kingdom and the Foreign Language Club is ready for their adventure. Each student on the trip boarded the plane with
300 pounds. That little L is pounds.
They each brought additional U.S. dollars with them to exchange as needed. The exchange rate from U.S. dollars to British pounds is 0.62222 pound to every dollar.
So at the time that this book was written, take a look at 0.6. Just in your head, one easy reference is 0.6 is close to 0.5. So you're getting a half a pound for every dollar. All right? That was a while ago. Okay, it's not that bad anymore. But if you're going from one country to the next, the dollars don't necessarily equate. Okay? So when this guy was going on his trip, which wasn't that long ago, this book was just published, I think, last year, 0.5-ish pounds for every dollar. So less buying power for U.S. dollars if you're traveling that direction. Write a function to represent the total amount of British pounds each student will have after exchanging additional U.S. currency. Define your variables. We've got dollars and pounds. What do we want to use for symbols?
Pound sign.
Pound sign? Or do you want a P?
A P.
Because a pound sign looks like this. All right? It probably comes from, a lot of times you'll hear that money called sterling. I think maybe it was sterling silver that was what their money used to be based on. So that's the pound sign. Let's call it P. What are we exchanging pounds for? Dollars. So if you want to end up in pounds and you're trying to figure out if I'm bringing over dollars, how much pounds do I have? We'll call it a function of P for every dollar D. How many pounds can we get per dollar D? So the students are starting out with a certain number of pounds to begin with. What's their starting amount?
300.
300. So that 300 is already in pounds. Does it need to be converted? Do you want this to go higher? I see a lot of you stretching your necks. Here we go. That 300 is already in pounds, but some students are bringing more than that. So we're all taking a math field trip. And part of the price that we told the parents is you need to pay for your ticket and they need a little spending money. So all the parents set up ticket price and this much pounds. But some of you have been working summer jobs or have rich grandmas or something, so you're going to be able to bring a little extra. Only thing is, your extra is coming in dollars. Here's what you're going to have to do with that little extra. You're going to take the dollars and times it by something. What are we going to times the dollars by? 0.6222101. Martine, I need you to stop that and do this right now. Times dollars. So, Mr. Vega, what this means is I'm starting with 300 pounds. I'm going to add to that about 62 cents or pence per dollar. Okay, so that it's getting exchanged over. Every dollar I'm going to times by this. It's a little bit half as big as a dollar. All right, so that's our function. But defining variables, P equals pounds and D equals dollars. Aha, interesting. Maybe I need to keep the function there. Number 2. What do we need to do, Wyatt, in number 2?
Identify the slope and interpret its meaning in terms of this problem situation.
Slope. We just spent a lot of time yesterday and the day before looking at functions and figuring out where to find the slope. So in this, what did we find yesterday on all of our graphs? We were dealing with x's and y's. So here's some linear equations. Where was the slope at? Say we were looking at b right here. Where do we find the slope? In front of the x. And then d was a slightly more complicated linear equation, but where would we find the slope?
2x.
In front of the x again. So in front of the x here, and in front of the x here. In this function, folks, take a look. We don't have an x. What do we have instead of an x?
A p.
We have a p way over here. That's kind of like our y. D. But 300 isn't a letter. Is it in front of a letter? Oh, here's what we're talking about. Not the 300. Maybe this would help if I rearrange this. P of D can also be 0.6220101D plus 300. I did this at first because I wanted you to focus on we're starting with 300 and adding a little bit based on how many dollars. But if you look at it in y equals mx plus b form, you would put the variable term and then the constant term. So now, if I'm looking at this function this way, my variable is d. So what's the slope?
0.62211.
The number that's in front of a letter is 0.6220101. Now that, I sure like it better when it's a 2. Gosh, 2, very easy to look at. I can understand what a 2 means. But guess what? The real life isn't simple. The British currency isn't, oh, we'll just give you 2 for 1. That would make our math a lot easier. And in a lot of math classes, we'd only focus on these kind of equations. One thing that's different about this math class and Common Core math is you're using real stuff. Hey, the real stuff is a little more complicated, but we have a calculator. Here's the feature, though. That was in front of the variable. That was in front of the variable. Everything we looked at yesterday, our variable was an x. Today, our variable is $1. Why is it a variable? Because Molly's going to bring a certain amount of money, Andy's going to bring a certain amount of money, and Jerry's going to bring a different amount of money. It varies from student to student. So this D could be $200. This B could be $50. This B could be $0. It depends on what you're bringing in your pocket for spending money and trying to convert on over. That's the whole idea of a variable. Okay, slope equals 0.6220101. And what does this mean? Where did we get that number originally in the situation?
That's the exchange rate.
That's the exchange rate for pounds per dollar.
Iggy Azalea, oh yeah.
That's the exchange rate, pounds per dollar. So our slope is kind of ugly looking, kind of decimally. I wish it was a 2, but Real life isn't that simple. That's okay. You have computers, you have calculators, we can deal with it. We just need to know where to find it, and it was in front of our variable. Identify the y-intercept. So now we go back to that function up there. We figured out where the slope is. What's the y-intercept? Now, that's the number added to the variable term. The y-intercept is 300. What's that 300 in the problem?
That's where it intercepts in
That's where it's going to intercept on the graph, but in the problem, where does the 300 mean?
plus the $300. How many pounds you have?
How many pounds you had to start, not dollars. How many? Yeah, you were thinking the right thing, but we'll use the right words. This is 300 pounds. Let me make that right. This is the starting money or spending money for every student. So everybody had at least that for a minimum. That was built into the trip expectation. You're going to need to buy lunch, okay? But some people brought more so they can pick up some nice shirts, some new hats. I don't know what they were shopping for. Flip the page. Dawson. Dawson would like to exchange $70 more. Here's what Jonathan thinks about that. Chris Bernal, could you read? Jonathan thinks.
He's not here to solve.
Dawson.
Jonathan thinks Dawson should have a total of 340. 40.547 pounds.
Aaron says,
have a total of 343.5
and Trey
pounds.
says,
And Trey says he should have a total of 342 pounds. Who's correct?
Hoosiers.
Reasoning is correct. Why are the other students not correct? Explain your reasoning. Blake, shut it.
Okay, so wait a minute. Did we miss something? Did they give us a certain amount of money? No. Unless, yeah. Okay, so we're good. But look over here. This little guy in his speech bubble has a clue that's going to help us answer this problem. Tony, can you read the speech bubble?
The pounds are made up of
100 pence.
100 pence. Just like the dollars, this is made
it's
up.
honors.
Excuse me. Thank you. So the pound is made up of 100 pence, just like dollars made up of 100
Cents.
Okay, so if we were going to talk about how much money is in Myra's bank account, would we say 343.54707? Would we talk about money like that?
No.
No. So their decimal system is similar to ours, 100 pence where we have 100 cents. So we have three choices. This choice, that choice, and that choice. What choice makes more sense?
The
342.
342.55.
Okay, I've heard three different answers right now. Right now, at your table, all right, you're looking at three choices, this one, and this one. I want you to decide which one makes more sense if we're talking about money. Okay, we'll take 1 minute. I bet you we can do 30 seconds. 30 seconds starting now.
343.